So JUnit 6 is just released early this month. And you know what's funny? The previous version, JUnit 5, came out way back in September 2017. So do the math with me real quick. That's 8 years between major versions. And this release is weird. Because if you haven't been around during the JUnit 5 launch, let me tell you, JUnit 5 was a big deal. Okay, so it was like a complete architectural rewrite. They tore down everything that was JUnit 4 and they kind of rebuilt it from the scratch. And the whole pitch there was we are doing the painful rewrite now so that the future updates can be easier and faster. That was the promise, right? Faster evolution going forward. And that was 8 years ago. So naturally, you would think 8 years later, JUnit 6 is being released. It must be packed with features, right? And I'm looking at the list and going, well, is this it? Like 8 years of work and we get this? What am I missing here? We have a Java version bump, some quality of life improvements, and basically this is a maintenance release. So what happened? Did the architecture not deliver on the promise? Or was there no need to ship anything? In which case, why did they even do version 6? Why not keep shipping version 5? And we are not talking about a small user base here, right? JUnit 5 is massive. There are thousands of companies, probably millions of projects. It's basically the default testing framework for Java, right? Everyone's using it, it's stable, it's working. So what is the reason to force all those teams, all those organizations to deal with a migration for what basically looks like housekeeping? I'll tell you why. Here's what's being released in JUnit 6 though, okay? So they're requiring a new version of Java now. So it's Java 17 instead of the old Java 8. They've added nullability annotations that help catch potential null issues with static analysis. And I'll cover a little bit of that in a bit. And if you're writing tests with Kotlin instead of Java, there's better support for some Kotlin syntax. I'm not going to cover that in this video. They replaced CSV parsing library that JUnit uses internally for parameterized tests. There is a feature called parameterized tests where you can pass different parameters to tests. There was a CSV parsing library that JUnit used internally. They were using one, now they're using another. And they've unified the version numbers for all the different components in the JUnit architecture, right? So there was this platform, Jupyter, and Vintage. There were different modules. And for some weird reason, platform was 1.x, while Jupyter was 5.x with JUnit 5. Now with JUnit 6, everything is version 6 now. And if you read the release notes and the community discussion, everyone pretty much agrees, yeah, this is just a modernization release. It's a maintenance release. JUnit is catching up with the times, doing some housekeeping, cleaning out old code that nobody is using anymore. So that's basically it. It's not flashy. It's just maintenance, keeping things current. And that's not a big deal. But the question is, why is it JUnit 6? Why not JUnit 5.11 or 5.12? Why force millions of projects to update their build files and deal with the migration, even if it's an easy migration for what looks like housekeeping? Well, here's what's actually happening, right? We all know that most frameworks, most software projects accumulate tech debt, right? You make compromises, you depend on libraries that seem fine at the time, you support old versions of things because breaking compatibility is scary, and you just keep kicking the can down the road. Over time, one of two things happen. Either you do a massive painful rewrite, you rip everything out at once, or the project slowly declines because you can't evolve anymore. We all know that we should intentionally pay down on the tech debt, but the question is when, right? You got to pick your moments, especially for large frameworks like JUnit, where there are thousands and thousands of projects that are depending on it. You have to pick the right time to solve the tech debt and break compatibility. Not because you have to, but it's really the right time to do it. And that's what JUnit 6 is. It's not a maintenance release that happened to take 8 years. It's not 8 years of work. It's a strategic decision about when to break things. They were waiting, and now they've decided to do this. Because here's the thing. Every single one of those boring changes that I talked about, they all have one thing in common. They're all breaking changes. Small ones, minimal disruption, as the team itself puts it. JUnit team says it's a minimal disruption change. But it is a breaking change nonetheless. And here's why it matters, specifically for a testing framework. In my opinion, at least, no one wants to upgrade their testing framework. No one's excited about, oh, I want to try JUnit 6. That looks cool. I mean, think about it. Your testing framework isn't a feature, it's not something that users see, right? It's just infrastructure, it's background stuff. So as long as it's working, there's usually zero motivation to touch it. No one's excited about bumping up and getting the latest version of JUnit. So even if it's a small breaking change, even something as simple as, okay, you got to go update your build file, build.gradle or pom.xml, that creates friction, right? That creates a decision point. Do I really need to deal with this right now? My tests are working fine. Everything is fine. Why do I even need to take on the small migration? I think the JUnit team knows this. All these changes, they could have shipped it way ahead of time, but they waited to group them all together. Okay, so Java 17 is the minimum Java version that you need. Okay, it's not like JUnit 5 does not work with Java 17. Now with JUnit 6, they're dropping support for all the previous versions. And the platform being one version, the others being another version, the CSV library swap, these could have been done sooner. But every single one of these would have been a breaking change. Every single one would have required you to make that decision. Should I do it or not? Should I update my build? Should I run my tests? Should I deal with any of those issues? So there are 5 separate occasions where you have to ask yourself, is it really worth it? And for a lot of people, the answer would have been no. Maybe later, I'm going to push it down the road. And they would stay on the old version and the ecosystem would fragment. But if you bundle all of this together into one major version, which by the way is what a major version bump is supposed to be, right? It's semantic versioning. When a major version is increasing, it's basically a sign saying this will break things. And that's why they've put this all in version 6 and not version 5.12. And now you have to make this decision only once, right? One migration, one set of build file updates, one round of testing, and then you get all the benefits at once. So the question is, why did they not do this before? Well, the answer is because they wanted to bundle this all together. So let me give you some examples about what these changes are and what are you getting with JUnit 6 and what they actually mean for you and should you update, how do you update? I'm going to answer all those questions for you, right? First of all, take the Java version bump. They're moving from Java 8 to Java 17. Okay, Java 17, when did it come? I think it was like 2021, September 2021. That was a long time in terms of software development. I know the old Java cadence was like, yeah, one version of Java stays for like 10 years. But now with the new cadence, you would say, yeah, 2021 was quite a long time ago. It isn't new, right? So why did they wait this long? Because if they had done it before and you were still on Java 8, and there are millions of code bases in Java 8, it was worse 3 or 4 years ago. If they had released it earlier, there's no way they could have upgraded to JUnit 6, period. That's a hard stop, right? Because that's a breaking change and people were using older versions of Java. And this is true even now. There are a lot of people who are still not on Java 17. They're not going to be able to upgrade to JUnit 6. It's just the fact. And they better start upgrading because of something else that I'm going to tell you. So basically the JUnit team said, we're drawing a line. If you're not on Java 17 or higher, this isn't for you. You can still use JUnit 5, right? And this is not a decision you make lightly because that's a huge upgrade that you need to do. Secondly, there's the version numbering thing, right? This one's kind of fascinating. Before JUnit 6, there were different parts of JUnit that had different version numbers. Okay, so there was this thing called the platform. And that was kind of like the core foundation that all these other things were built on top of, right? Platform was actually version 1 point something. And there's a thing called Jupyter, which would be on version 5 point something. It was the same release, but it were different numbers. And it was a little confusing. Now in JUnit 6, they basically said, okay, this is also version 6, right? Everything is version 6, makes things simple. And it's not that big of a deal, except you're going to have to update your build file. When you're bumping up to JUnit 6, well, your build file has to be updated unless you're automatically fetching it. If you're depending on platform in your build file, you're going to have to say, no, this is not version 1.x anymore. It is 6.x, right? You're going to have to go to your pom.xml or Gradle build and change those version numbers. And if you have multiple modules, you're basically doing it multiple times. It's a small thing. It's just a few minutes of work, but still it is friction and it is breaking. And it is something that I'm sure people will go, nah, I don't want to do it now. I'll do it later. So that's another thing why they've kind of waited and they've said, okay, we're going to put this all together. The next change is the CSV library swap thing. So what's happening here? JUnit uses a CSV parsing library internally when you write parameterized tests with CSV data. Okay, so basically you have a test and you want to pass in different set of arguments to a function. Well, what do? You can basically just call that same function again and again and again in your code, or you can say, here are the list of my parameters. Now I want you to run the test for each of these combinations. Okay, so let's say they can add method. You want to test an add method with two numbers and make sure that the output is the sum. So you can say 1, 1, you want to make sure it returns 2, 3, 2, you want to make sure it's 5. So you basically have input and output combinations, right? You can separately invoke this in the code, but then JUnit has a feature where you can provide all this in as a CSV format, right? And you give it to the JUnit infrastructure and you say, well, here are my inputs and here is my output. You just run this on all these combinations and make sure it works fine. So you write it in comma separated format. And JUnit used a CSV library internally, parse this, and pass it to the test functions and make sure that they return fine. So they were using a library called University Parsers. Okay, University Parsers. It did the job. It worked fine. But now, if you look at the library, the last release was over 3 years ago. Okay, the last commit to the repository was it was almost 3 years ago. And I haven't looked. Let's take a look at this one. You see here there's a website link, and if you click on it, this link is down. So the website is down. Nobody has touched this library for 3 years. So it's abandoned? Well, not officially, maybe, but all practical purposes, I think this library is done. So what some frameworks do in this situation is they just keep using it. It's like, this version works, we're just going to keep going. Okay. Or they have to copy the code and then maintain it themselves. But JUnit said we are swapping it out, especially because there are other changes that are happening. Java compatibility issues might come up. So they're like, no, we want to pick a newer library. So when you do this, when you swap the CSV parsing library, the behavior changes somewhat. Maybe the new library is stricter about what it accepts. If you had malformed CSV data in your test, the old library was lenient about it. New library is like, no, this CSV has a format. It throws an exception, your test break. So this is a breaking change. You might think this is implementation detail. I'm just using JUnit's API. Why should the internal library that JUnit uses matter? Well, in theory, that's fine. You're using the JUnit API, it's JUnit internals. But in practice, if you have some nuances in the CSV that the library handles differently, the new library handles differently. Maybe it handles white space differently. Maybe it handles trailing comma differently. It wasn't properly escaped or whatever, right? Suppose the old library lets it slide and the new library says, no, that's an error. Well, your tests were passing yesterday, but now it'll break because the JUnit's internal API has changed. So that's a potential breaking change, something that most people don't think about, but that is a possibility. So again, they waited for a while and then they said, okay, now we're doing a breaking change. Let's bundle this thing in. Let's use this breaking change opportunity to clean out the old CSV library, and then they updated the new CSV library. And if you look at this release, you'll see the same pattern everywhere. Take the nullability annotations. Okay, so this is yet another change that's new in JUnit 6. Let me explain what this is and why you need to know about this. So in Java, I'm sure you've come across null pointer exceptions. Okay, you use something which you think has an object, but then it's null and then you get an error, right? Java doesn't really tell you. You have optional, but not many people use optional. So at runtime, you don't know if something is null or not. So you have to add a bunch of null checks. It's a pain. So nullability annotations are a way for you to mark a piece of code or a variable and say, this thing will never be null, or this thing might be null. Check it first, right? You can do that for variables, you can do it for method arguments, whatever, right? And once you have that, your tools, your IDE, your static analysis tools, compilers, they can all use this annotation to warn you and say, hey, you're passing something that might be null to a method that expects it to never be null. This is going to break, or you have to do null pointer check here, right? So here's an example of what it looks like. You have a non-null annotation, which says this thing cannot return null, right? You annotate a method and say this cannot return null. And then you have a non-null annotation for a method argument. It says this thing cannot accept a null. And then you have a nullable argument, which says this can be a null. So if you have a nullable, you're going to have to do a null check. It's handy. You know that something can be null. And then with this one, you have this guarantee that it'll never be null. So when you're writing JUnit tests, you can use this information. The IDE can immediately warn you when you're trying to do something unsafe. So JUnit is this annotation aware, and it shows up in various different places where it knows what the intention is, and it's really useful when you're writing tests. At the same time, the JUnit APIs are annotated as well when it is available. So you can look at the JUnit APIs and know which ones is nullable, which one is not null. It's pretty useful, right? It catches a whole categories of bugs at compile time instead of at runtime, especially with tests. You want to catch them sooner. So people have been asking for this in JUnit for a long time. And there have been a few annotations that the team had considered. Because, okay, you want static null annotations. Which annotations to use, right? Because Java doesn't have built-in nullability annotations. So there have been different projects. So there was a JSR 305, I think, which Spring uses, which is the old specification for nullability, but it wasn't officially adopted, but it's still being used, right? There are a bunch of others. So if JUnit wanted to add nullability annotations, they would have used that 5 years ago. But whatever they picked, it would have been a decent choice, but they would have had to risk the industry basically moving on and settling on something else because it was kind of like debated at that point. That would have been another breaking change. So basically they waited. And now there is this thing called JSpecify. JSpecify is basically this industry consortium trying to solve this specific problem. So there's a bunch of companies. There's Google, there's JetBrains, Oracle, Uber, and even the Spring team. They're all major players together who are saying, well, let's create a standard for the nullability annotations that everyone can use. And they took their time and hashed out the details. And they created this thing called JSpecify. Version 1.0 was released last year, I think. And now, this year, JUnit has adopted it. Right at the time that Spring Framework also is migrating to JSpecify, right? So that's the strategy. So they waited. It's not like it took this much time to build this annotation feature in. It's just that it's easy to build, but they were deciding when to make it available and make it a part of the framework. And now they've decided to do it with JUnit 6, right? Another thing with JUnit 6 is the Kotlin support. This also follows the same pattern. Rather than release them separately in several versions, they chose to wait and bundle them into one version. So you can see the pattern here, right? Each one of these is a decision that the framework has done, right? They've identified the tech debt, the unmaintained dependency, the confusing versioning, and the language support problems. Waited for the right moment. When the ecosystem stabilizes, when the standard emerges, then we have a solution, and then they kind of bundle that pain. Don't break compatibility at several times because JUnit is used so often, so extensively, so they just break it once and with a plan. So that's a strategy. That's the why. And now here's a practical question. If you're sitting on a JUnit 5 code base right now, what does the migration actually look like? The official line is that migrating from JUnit 5 to JUnit 6 this is what they say. It says much easier than migrating from 4 to 5, which is true because 5 was like a huge change. Like I said, they had completely re-architected the whole thing. This is nothing like that. But easier doesn't mean zero work. Some things will break. Be specific about what you expect. First of all, you got to make changes to the build files. Every JUnit dependency that you have, it was 5, now it'll be 6. So you got to open up your pom.xml or your Gradle file, and you're going to have to update the version numbers. If you have multiple modules, you're going to be doing that in multiple places. Not a big deal, but it is work. It has to be done. What the team says is like it should be smooth sailing, just upgrade it. They don't anticipate any problems. Next, CSV parameterized tests. If you're not using the parameterized tests, the CSV source or CSV file source, then you don't have to worry. Those tests, all the other tests are fine. This only affects those CSV sources for parameter, like different combinations of parameters that I talked about. If you're not using CSV, no problem. If you're using that, just make sure you run it and make sure that the new choice of the CSV parsing still works for you. It works, then great, no worries. If it starts failing, you're gonna have to look at what is the nuance in that CSV, maybe the extra white space, extra comma. Make sure that the new parser is just as forgiving as the old parser. If not, then you're gonna have to do it, okay? This is something I think it's useful anyway. Like it's probably gonna point out issues with the way you have structured your CSV. It's annoying, but it's good to basically clean that up. If you're a Kotlin user, your tests are going to get better because JUnit has better ways to call the suspend function in Kotlin, which I'm not going to get into. That's an additional feature that you can start using, right? If you've been ignoring deprecation warnings they're going to come bite you now. Okay. So the JUnit's policy is that they only remove APIs that have been deprecated for over 2 years. So if you've got code using the old deprecated stuff that's been warning you since 2023, that code is going to break. And the migration support module, the thing that helped you bridge from JUnit 4 to JUnit 5, that is now deprecated too. So they introduced a module in JUnit 5 to kind of help bridge the migration. They're removing that, right? You don't need that now. You're gonna have to, you have had enough time to upgrade all that changes, upgrade all the tests. So you're gonna have to write it in the new way now, right? It still works in JUnit 6, but that this is your heads up. The next major version, that thing is gone. So what should you do? Should you upgrade? Here's the formula. Here's what you need to check. If you're on Java 17 or higher and you're currently using JUnit 5, honestly, I think you should just upgrade. The migration is pretty low risk. Okay, try it on one module first, upgrade the dependencies, run your test suite, see what breaks. Most likely it'll be your CSV test if you're using them. Otherwise, it should just work. Once that module is clean, kind of roll it out. For most code bases, we are talking about like a few days of work. It should be not much. If you're on Java 11 or earlier, anything lesser than Java 17, you should not migrate yet. But seriously, your blocker isn't JUnit, it's Java, all right? JUnit 5 is going to be supported for maybe another 1 year. So you use this time to plan out your Java upgrade first, right? Get to Java 17 and then come back and think about JUnit 6. And don't do them both at the same time. First, get the Java upgrade done, make sure that works, and then maybe think about doing JUnit 6 because this is a much higher priority migration that you need to do. If you do it both together, you're asking for a lot of pain. And if you're on JUnit 4, man, we need to talk. The JUnit vintage engine, right? The thing that lets JUnit 5 and 6 run your JUnit 4 tests. That's, like I said, it's deprecated now. That's going to go away. You probably have about 12 to 18 months before that becomes a real problem. So if you haven't already started planning your migration to Jupyter, you have to do that now, okay? So JUnit 6 doesn't make that migration harder. The APIs are still the same as JUnit 5, but the deprecation of vintage is a clear signal that, okay, that bridge is closing. So that's what you got to do. That's higher priority. And the reason I'm saying this is that I completely understand that these are years and years old. This is a decade old technology. But the fact is, we in the Java community are very, very slow to adopt new technology. And I'm sure there are a lot of code bases that's still using Java 8, JUnit 4. So the time is running out. You better start upgrading those. So this is JUnit 6. 8 years they've waited and they've released this and they said, now is the time. You got to get moving, right? So is this the right strategy? On the one hand, I get it. One migration instead of 5 is definitely better, especially for the kind of inertia that the Java community has, like I talked about. It does make sense. On the other hand, 8 years is a long time, right? How many teams are still on JUnit 5 dot something from, I don't know, 2020 and they haven't bothered to upgrade? How many code bases are still sitting on Java 11 and thinking, yeah, we'll get to that eventually? It's a lot of fragmentation that happens because people don't want to deal with the migration fatigue. And it makes sense. People don't want to invest in something that doesn't affect their bottom line. So bundling all these changes together is basically potentially causing some people to, they may never take that bundle. They will just stay with the old version. So I'm kind of in two minds about whether these frameworks that operate on the Java ecosystem, is it better for them to kind of hold off and release in batches? Or is it actually better to make small incremental changes in an attempt to kind of push that inertia, right? To motivate people to change. Maybe if they had shipped Java 17 support in 2022, more teams would have been in modern Java by now. It's kind of like a chicken and egg thing, right? The community doesn't upgrade fast because there are these long releases, and there are these long releases because they think the community doesn't upgrade fast. I don't know. There isn't a perfect answer for this, but the JUnit team has made a deliberate choice about how to manage this kind of a tech debt in this extremely widely used framework. They have bundled the pain and they've committed to it fully. And I can understand where they're coming from. So this is JUnit 6. You may not upgrade right away, but this is something you should know and plan an upgrade for, because The longer you wait, maybe you can push at most for a year. A year from now, it's going to be a problem. So start working on it, okay?